Imagine a tiny device, running endlessly, providing clean, limitless energy for everyone. What if scientists announced they had created such a thing, right in a lab? This was precisely the promise that electrified the world, sparking immense hope and curiosity. The dramatic early claims surrounding cold fusion were fueled primarily by a potent mix of perceived revolutionary potential, sensational media coverage, and the perceived simplicity of the experimental setup, creating an intense public and scientific fervor. At its core, cold fusion proposed generating nuclear fusion energy at room temperature, completely bypassing the extreme heat and pressure required for conventional hot fusion, like that found in the sun. This concept, if true, represented an unimaginable breakthrough for global energy supply. The why behind the excitement was the idea that two very common elements, palladium and deuterium, could fuse simply by running an electric current through them in an electrolyte solution. This seemingly simple setup suggested an accessible, abundant, and non-radioactive energy source. This situation highlights how crucial the scientific process of peer review and independent replication truly is. When extraordinary claims are made, the scientific community rigorously attempts to reproduce the results using identical methods. If experiments cannot be consistently replicated by other independent laboratories, the initial claims lose credibility. For the public, this means approaching any groundbreaking scientific announcement with an understanding of this necessary verification step, waiting for consensus rather than immediate acceptance. Early on, researchers Stanley Pons and Fleischmann held a press conference, which bypassed traditional peer review journals. This move, while generating immediate buzz, also meant their claims were not yet vetted by the broader scientific community. Their announcement included claims of excess heat generation and even tritium production, both indicators of nuclear reactions. The allure of seemingly clean, cheap energy was so profound that even without full verification, the initial announcements captivated headlines globally. Ultimately, the dramatic early claims faded because, despite extensive efforts by numerous research teams worldwide, no consistent, independently verifiable evidence of cold fusion was ever found. This saga serves as a powerful reminder of how initial optimism and media enthusiasm, however well-intentioned, must always be tempered by the methodical, rigorous demands of scientific proof and reproducibility, ensuring that only robust and reliable discoveries move forward.